This is lesson 2.6 and we have been studying functions, and so now we're going to perform operations with functions. We're going to see what happens when we add two functions together, when we subtract two functions, when we find the product of two functions, and when we find the quotient of two functions. There is one other operation we'll do, and I'll discuss that in a few minutes. For each of these, we will talk about the domain. Now, if an original f function has all real numbers as its domain, and g has all real numbers as its domain, no exclusions, then the sum, the difference, and the product will also have all real numbers as their domains. The quotient will have all real numbers except any x value that might cause the g function to take on a value of 0. Then that would have to be excluded. So let's take a look at working with sums, difference, products, and quotients. All right, we start out with two functions. Up here we have f is 6x plus 4 and g is x plus 2. So f plus g of x is the sum. It is 6x plus 4 plus x plus 2. I can drop the parentheses off, and that gives me 6x plus 4 plus x plus 2, which is 6x and an invisible 1x, gives me 7x plus 6, 4 and 2 gave me 6, and that is the sum function. Because both the f and the g have the domain of all real numbers, then so does the sum. And negative infinity to positive infinity implies every number in the real numbers is in that domain. Now, the difference. The difference function, f minus g of x, is the f function, 6x plus 4, minus the g function, which is x plus 2. I can take the first set of parentheses off. The second set, remember, I can do change to addition, opposite, opposite, or you could have used distributive property. So now I have minus x and minus 2. That's 6x minus x is 5x. 4 minus 2 is 2. That's my difference. The domain, again, is all real numbers. The product, f g of x, is the f function times the g function, and the kind of multiplication I'll use in this example is FOIL. Product of the first is 6x squared. The outer product is 12x. The inner product is 4x. Product of the last is 8. That gives me 6x squared plus 16x plus 8, and that is the product function. The domain continues to be all real numbers from negative infinity to positive infinity. We have our last part, and it's f divided by g of x. Put the f function on top, 6x plus 4, over the g function, which is x plus 2, and that's all you type in. You don't have to actually try to do any of the division. But the domain, you have to find exclusions because you now have a rational function. So you take the denominator, x plus 2, and remember, if it's equal to 0, you have an exclusion. X equals negative 2 is the exclusion. That means that we're going to go from negative infinity to -2, but put parentheses around the -2. It's always around infinity, but around -2 to say it's not included. Union with, open parentheses, -2 to infinity. This might seem odd, but what it's really saying is, if this is the real number line, from -infinity to -2 is here, and then on the other side of -2 to positive infinity is here. This is, in interval notation, how you express that there is a gap at -2. So the domain here is right there. All right, let's look at another example. This time f of x is x plus 1, g of x is 4x squared. So f plus g of x is parentheses x plus 1 plus parentheses 4x squared. So that's x plus 1 plus 4x squared, and I'm going to write it in descending powers, 4x squared plus x plus 1. That's my sum function. If these were functions, then the sum of them is also a function. The domain of f is all real numbers, no restrictions, no exclusions. The domain of g is all real numbers, no exclusions. That means that their sum is all real numbers as its domain. Looking at the difference, I have f minus g of x is, let's see, f is x plus 1 minus g is 4x squared. So that's x plus 1 minus 4x squared. I will lead with minus 4x squared plus x plus 1. That's my difference, and the domain is all real numbers. The product, f g of x, is the f function times the g function. This time I'll use distributive property from the right side. That's going to give me 4x to the third plus 4x squared. That's my product function, and the domain continues to be all real numbers. Finally, the quotient. I have f divided by g of x is the f function over the g function. That's the quotient. Type that in there. Now, the domain, you have to find exclusions. If 4x squared equals 0, divide by 4, x squared is 0, and that means x is 0. That's your exclusion. In interval notation, it means the domain is all real numbers except 0. So it's from -infinity to 0, union 0 to infinity. Now, by using a parentheses here and a parentheses here, that is telling in interval notation 0's not included. So it is this one. All right, as I mentioned when we started, we're going to add, subtract, multiply, and divide functions, but that there is an additional operation. This operation is composition of functions. This might sound odd, but you're going to put a function inside another function. So if you have f composed with g. The symbolism is f little circle g of x. That means it's f, you always start with the first one, of g of x. So g of x is going to be put in the place of x in the f function. If you look at this drawing, which kind of tracks what goes down, you have an input x. It goes into the inner function, g, and out comes g of x. That turns into the input of the f function, and then finally you get output again. We will talk more about domain of this at the very end of the lesson. All right, number 3. We've got 3 parts. Part A. It says to find f composed with g of x. Now by definition that means f of g of x. Now the f function, which is the outside function, the f function is called 5x. So it is 5 times something. 5 times what? 5 times g of x. But what is g of x? It's 5 times, look back up here, x plus 4. So what I've done is take the g function and put it in the place of x in the f function. Now that the g function has been placed, now that the g function has been placed inside f, simplify. 5 times x is 5x, and 5 times 4 is 20. So this is 5x plus 20. If I reverse it, and I'm supposed to find g composed with f of x, that means that it is g of f of x. The g function is something plus 4. What? Well, I'm supposed to put f of x in there. But what is f of x? It is 5x plus 4. I can't combine like terms, so that's it. Now to find f composed with g of 3, the quickest way is to just go up here and get the definition for f of g of x, which is 5x plus 20. So that's 5 times 3 plus 20. That's 15 plus 20, or 35. That's the quickest way. If you don't have this function, then it is a longer process. But we do have it. So now let's look at, I'll put D right here. We're supposed to find g composed with f at 3. Well, g composed with f is, here it is, it's 5x plus 4. So when x is 3, it's 5 times 3 plus 4. It is 15 plus 4, which is 19. So as long as you already have f composed with g for any x, which we had in part A, you just plug 3 into it. And we had g composed with f of any x, and we plugged 3 into it. Let's look at problem number 4. I think I'll start down here. We have A, we're supposed to find f composed with g of x. That means f of g of x. So g needs to go into x, the f function for x. Now what does the f function looks like? It looks like x plus 1. But in the place of x, you're going to put g of x. Well, what is g of x? It is 4x plus 4 plus 1. So it is 4x plus 5. If I reverse that, g composed with f of x, that is g of f of x. Well, let's see. The g function is 4 times something plus 4. 4 times something plus 4. But what is the something? It's f of x. So it is 4 times x plus 1 plus 4. Distributive property, that's 4x plus 4 plus the outside 4. So that is 4x plus 8. Hopefully you can see right now that composition, it is an operation. It is not commutative, because if it were commutative, those would be the same, but they are not. Let's look at part C. Part C says to find f composed with g evaluated at -1. So I'll come down here and say, oh, so that's 4x plus 5 evaluated at -1. It's 4 times -1 plus 5. It's -4 plus 5, which is 1. Because I already had the f of g function. All I had to do was plug in -1. Part D says to find g composed with f at -1. So the g composed with f function is 4x plus 8. Evaluated at -1, it's 4 times -1 plus 8, which is -4 plus 8, which is 4. So when you reverse the composition, you don't get the same thing. Let's look at number 5. Very, very similar questions. The first thing I'm supposed to find for part A is f composed with g for any x. So that's f of g of x. The g of x function is going into the f function. So I'm going to take g and I'm going to plug it into f. That means that I get 3 parentheses 2x squared minus 2, close, minus 5. So you can see the outline, 3 times something minus 5, 3x minus 5. But what goes in the place of x? The g function. Distributive property, that's 6x squared minus 6 minus 5, which is 6x squared minus 11. And now we reverse it. G composed with f of x. Now the g function is 2 times something squared minus 2. So let's go back up here and I'm going to erase something. This time I'm going to plug this 3x minus 5 in the place of x in the g. So I'm going to put 3x minus 5 right there. Now I have a bit of extra algebra to do here, so I'd like some more space. Well, there we go. I guess you can catch your breath or get a cup of coffee while I try to do this. There we go. So I need to remember what Aunt Sally says, exponents before multiplication. So I need to square this binomial. So it's going to be 2 parentheses. To square a binomial, you square the first, so that's 9x squared. Multiply for negative 15x, double it for negative 30x. Square the last one for plus 25 minus a 2. Now distribute. That's 18x squared minus 60x plus 50 minus 2, or 18x squared minus 60x plus 50 minus 2 is 48. So that was a good bit of work doing it that way, because I did have to square that binomial. So 18x squared minus 60x plus 48. When they asked me to find, for part C, f composed with g evaluated at -1, then I'm going to take this function 6x squared minus 11 and put in -1, so it's 6 times -1 squared minus 11. Well, -1 squared is 1, times 6 is 6, minus 11, which is -5. Part D, where they asked me to find g composed with f, also evaluated at -1. I'm going to take this function's definition, which is 18x squared minus 60x plus 48. 18 times -1 squared minus 60 times -1 plus 48. You can do that on the home screen of your calculator. Make sure you put the -1 in parentheses and you will get 126. All right. Problem number 6. We're going to look at the domain of this, but we're not going to spend a lot of time on this in our course. If you go on to pre-calculus, you will. The first thing it says is to find f composed with g of x. Okay, that means f of g of x. The g function goes into the f function. All right, so that's going to be 8 over, because I'm writing the f function, but in the place of x, I put 1 over x plus 3. Well, that's kind of a mess, but we know that that is a complex fraction, and hopefully you remember that it is type 2. The common denominator is the only denominator, which is x. So I'm going to multiply the top by x, this term by x, and this term by x. I hope you remember this simplifying process. This gives us 8x over, these divide out, 1 plus 3x. This is the composition. So this is the answer you will put right here. Now, the domain. you have to look for exclusions in two places. One of them will obviously be down here, but you have to check exclusions in the original f function, in the original g function. Let's go back up. There we go. Almost. Right here. The domain of a composition, f composed with g, is a set of all x's such that x is in the domain of the inner one, g, and g of x is in the domain of f. So what you really have to look at is start with the inner function. So exclusions based on g. Well, what was g? G was 1 over x. So since g of x is 1 over x, I hope you all agree that x can't be 0 because the denominator can't be 0. Then you look at exclusions based on the last function. So now I'm going to look at f composed with g of x, which is 8 over 1 plus 3x, and its exclusions, well, you'd say 1 plus 3x cannot equal 0, so subtract 1, so 3x equals negative 1, divide by 3, x equals negative 1/3. This is a domain exclusion, and this is a domain exclusion. It would be so nice if you could just say that in words, but MyMathLab wants it in an interval, in intervals. So think about the number line with negative infinity and positive infinity. Negative 1/3 would be, say, here. 0 is bigger than negative 1/3. It would be there. These must be excluded. So that's okay, and that's okay, but you must show holes at those. So it will be from negative infinity, comma, negative 1/3, use parentheses, union, and that symbol is available for you to type from the toolbar, negative 1/3 to 0, parentheses, union, parentheses 0 to infinity. Now that is a good bit of writing to simply say x can't be 0, x can't be negative 1/3, but that's how you would have to type it. So you have to make sure if there is a domain exclusion on the inside one, and I say inside from this statement, you have to make sure you immediately exclude it, x can't be 0, and then when you plug it in, look at what you've got and see if any new exclusions have occurred, and they did. So you look at two. You look at the inside function, and then you look at the last composition function. All right, so those are the operations that we're going to look at with functions.